Good morning all. Welcome to my channel Vijay's Physics Sprint. Today we'll discuss about line of force, electric line of force. Last class I covered about Coulomb inverse square law in electrostatics. Now it is continuation, electric line of force. So what do you mean by the electric line of force? Electric line of force is nothing but the imaginary path of unit positive charge. How the positive charge will move, the direction indicated by imaginary path, the path it is called as line of force, electric line of force. And this line of force has some properties. So what are those properties? Very important, these properties, right? So the properties is nothing but the electric lines of force starts from positive charge and end to negative charge. Starts from positive charge and end from negative charge. And these lines of force is different for positive and as well as negative. If it is positive charge, for example, this is positive plus Q, single positive or isolated positive charge, isolated positive, and negative minus Q, this is isolated negative charge, isolated positive and isolated negative. For isolated positive, the lines of force are radially outwards, for lines of force. For positive charge, radially outwards. If it is negative charge, radially inwards, right? If it is electric dipole, what do you mean by the electric dipole? Two equal and opposite charges, equal but opposite charges separated by minimum distance, the arrangement it is called as electric dipole. Di is nothing but two, so two different charges but same magnitude, they have unlike charges separated some certain distance, minimum distance, that arrangement it is called as electric dipole. So for electric dipole, the lines of force, already I said, positive starts from positive charge and to negative. So starts from positive like this and end to negative charge, radially outwards and it is inwards. For electric dipole, if same charges are placed some certain distance, two equal charges, plus Q and plus Q, like charges, then what happens? These are the lines of force, repulse each other. So repulse each other means lines of force should be radially outwards like this. So this is the electric lines of force for two positive charges separated by some certain distance, and this is for equal and opposite, simply electric dipole, electric lines of force arrangement. So the first one starts from positive and to negative charge, radially outwards for positive, radially inwards for negative charge, and these electric lines of force for electric dipole, and like charges are separate from certain distance, and these are the lines of force for the given system. Now the next property is, now these lines of force never intersect, do not intersect. So these lines of force, just now I said to you for electric line dipole, the line of force do not intersect, If intersect, this is a third property, do not intersect. If intersect, what happens? If intersect, at that point, electric field intensity E bar has two directions, which is not possible, because electric field intensity is a vector having only one direction, but at the intersect point electric field has two directions, which is not possible, so that the lines of force are do not intersect. Next, fourth property, if I draw a tangent at any point on line of force, The tangent direction. The tangent direction indicates the direction of electric field intensity direction, E bar direction. Electric field intensity direction indicates the direction of tangent. This is a fourth property. Now, next, it is fifth property. It is, see here, one question is given like this: Q1, Q2, different, unlike charges, right? Imagine Q1 is greater than Q2, right? So now just imagine the lines of force in our question is given like this: Q1 is more and Q2 is less, right? So options are given like this. There is a question and options are given: Q1 is equals to plus 4 microcoulomb, Q2 plus 4 microcoulomb, and Q1 in second option plus 4 microcoulomb, Q2 minus 1 microcoulomb, Q1 minus 1 minus 1, and Q1 minus 4 micro, Q2 plus 5 4 microcoulomb. It is given like four options. Now which option it is correct? Just based on the electric lines of force properties, you have to choose the right answer. So Q1 lines of force outwards, so it is a positive charge. So positive charge means 1 and 2. Maybe any one of the option is right. And 3 and 4 is a negative charges, so third and fourth options absolutely wrong. Now Q2, it is radially inverse, means into the Q2 charge, so it is negative. So the right answer it is second option. Like you have to identify the correct option based on the electric lines of force. Next, the total number of lines of force. The total number of lines of force, it is called as electric flux. So one more property. The total number of lines of force, it is called as electric flux, indicated with the phi. So electric flux, total number of lines of force, total number of lines of electric force, flux. Just now we discussed electric flux. Electric flux is nothing but the total number of lines of force in a given area. The total number of lines of force, it is called as electric flux, represented with the phi. See, in a given surface, if lines of force are entering three surface, imagine this is A1 and this is A3 and this is curved surface, it is A2. If lines of force are entering into the surface, then flux, it is taken as negative flux. If flux are leaving from the surface, then flux, it is taken as positive. Entering into surface, negative. Leaving from surface, positive. Then at the curved surface, number of lines of force entering is same as number of lines of force leaving from surface. Therefore, flux becomes, it is 0. Entering positive, leaving from surface it is, this is negative, and leaving from surface it is positive. Next, one more property of lines of force, it is, I think this is 7 lines of force. C positive plus Q, lines of force are radially outwards. Already we discussed about this isolated positive charge. These lines of force are open lines, but whereas magnetic lines of force, if these electric lines of force compare with magnetic lines of force, magnet has two poles, north and as well as south. Lines of force starts from north to south, outside magnets. Inside magnet it is south to north, north to south outside, and south to north. These lines of force are closed lines, closed lines, but whereas electric lines of force are open lines. So remember the difference between electric lines of force to magnetic lines of force. Electric lines of force are open lines, but whereas magnetic lines of force are closed lines. So this is about lines of force, electric lines of force, and corresponding some properties. So based on these lines of force, so may one question will come in mains and as well as needs. Okay, so please like, share, subscribe my channel, support my channel.